Hello. So today what we're going to talk about is something called Newton's method, which is a way to approximate the zeros of a function using a function's derivative. So this could be really useful for approximating square roots of a number or cube roots or any type of root of a number, like the fourth root, fifth root, anything like that. Or say you have a function that's really hard to solve and that you don't know actually how to do the algebra on it, but you want to try to guess at the zero to a function. Maybe you need to know the zero and you don't have a calculator around, anything like that. So this is a way that back before we had graphing calculators that could easily do the math for us and spit out the answer, that mathematicians could find the zeros of these harder polynomials that they actually couldn't solve. So the way you want to go about using Newton's method is you want to make an initial guess, and you're going to call this x1. So this guess is for what you think the zero of a function can be. And if you have no idea, just pick a random number that works in the domain of the function. Because no matter how far away from a zero that you make this, Newton's method will eventually get you down very close to the zero. It just depends on how many times you have to do it in order to get your answers to be so close to each other, one after the other. So once you make your initial guess, once you have your x1, you want to go about finding a second guess or a new guess, which you're going to call x2, and then you're going to find x3, x4, and so on by using that formula. So your next guess is always just going to be your previous guess minus the y value at that x over its derivative. So we're going to do this and we'll see how it works. And what you want to do is you want to keep plugging into this formula until the difference between one guess and the next one is less than a certain accuracy, maybe 100th or 1,000th of a place difference, anything like that. That your teacher will either give you the accuracy that they want to figure out, so that way you know when to stop doing it, or they'll tell you how many times they want you to do it. And each time you find a new guess, so every time you do this process, you plug into that x to the n plus 1 formula, it's called an iteration. So that's just a good vocab word to know. So let's do two of these problems. So the first one, we're going to use 3 iterations of Newton's method to approximate a zero of x squared minus 2. So a zero is where the function is equal to 0. So in other words, if we set this equal to 0 and we're to solve it real quick, we would get that 2 is equal to x squared, or the square root of 2 is equal to x. So in other words, we want to approximate the square root of 2. So without using your calculator, that'd be really hard to do. So we're going to use Newton methods instead. So why don't we first make a first guess? So let's let x1, let's let it be equal to 1, because we know it's definitely bigger than 1, but it's going to be smaller than 2 because the square root of 4 is 2, and 2 is between 1 and 4. So in order to plug into Newton's method, we need to figure out what the derivative of this function is. So let's take a derivative real fast, which is really easy since it's a simple polynomial. So we know that f prime of x is going to be 2x. So now we want to find x2. So in order to find x2, we're going to do 1 minus f of 1. So f of 1 is just 1 minus 2, which is equal to negative 1. So we're going to have negative 1 over the derivative at 1, which is just 2, plugging into that f prime. So this is going to be 1 plus 1/2, or 3/2. So now I want to do the same thing. We want to find x3. And since this is 3 iterations, we're eventually going to find down to x4. So when we do that, we're going to do 3/2 minus f of 3/2 over f prime of 3/2. Now, the numbers are going to start getting a little dicier, a little harder to work with. So these are problems that you usually want to use your graphing calculator for. So if we use the graphing calculator, we're going to switch it into decimals now. We're going to get that x3 is 1.417. And normally you should take your decimals out to 3 or 4 decimal places because that's usually the amount of accuracy that you need. Anything more than 4 decimal places is usually not really that necessary, and it would mean that you're writing too many numbers. It would just take too long. So if we do this one more time, we would find x4 by doing 1.417 minus f of 1.417 over its derivative. So f prime of 1.417. When we do that, we get that our x4 is equal to 1.417 1.414, rounding to that third decimal point. And if you use your calculator to check what the square root of 2 is equal to, that is approximately 1.414. The difference between the two numbers actually doesn't happen out until further than the third decimal point. So that's a pretty accurate answer. So you might be saying, I have to keep typing this into my calculator over and over again. That's really hard. A nice easy trick for you on your calculator is to put in your y equals screen, put y1 equal to your function, and then make y2 your derivative. So put your derivative function in there. And then you want to go to your home screen. So this is step 1. So step 2 is to go to your home screen, and then hit whatever number you're making x1. So then I will write it as type x1 and then hit 0. And then hit enter. So that way all you've had is, like, for this one you would have hit the 1 key and pressed enter. So you just have 1, and then on the right hand side of your graphing calculator you would have 1. And then your third step is to set up this equation using the answer key and your y vars. So you want to set up answer, so ans, minus parentheses, y1 of ants divided by y2 of your answer, close your parentheses, and then hit enter. And then all you have to do is keep pressing enter for every iteration you want to do. So you don't have to keep even typing in this equation, you just keep hitting enter, 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 and then you can spit out your numbers. So y1 and y2 are under your y vars, which if you're looking at your graphing calculator, it should be the button that's right to the left of your clear. So you want to go over, you want to hit vars and then go over to y vars after you hit the key, and you want to go down to that first option, the function option. So if you're having trouble setting that up, you don't know where all the keys I'm saying are, try and ask a friend or your professor and they can probably help you out with this. But that's a really simple way to do these, because that way all you have to do is set up the equations in your y equals screen, set up your initial guess and this equation, keep pressing enter, and you can do it as many times as you want. So if you start out too far and end up having to do 10 iterations, you don't have to keep typing in your function over and over again. So let's do one more. So we're going to use Newton's method now to approximate the cube root of 5. So that means we're going to make our function x cubed minus 5. And I know it's that because if I solve backwards from the cube root of 5 equaling x, I would cube both sides to get 5 is equal to x cubed, which is really 0 is equal to x cubed minus 5. So in other words, that's setting up the 0 for the function x cubed minus 5. So that's why I knew I wanted the function to be that. So I know for Newton's method, I need to find my derivative, which again is really easy since it's a nice polynomial. So we're going to hit 3x squared. And now I already went ahead and set up my calculator to use that calculator step that I was talking about before. So they told us what x1 is going to be equal to. So we're going to let it be equal to 3. Which is not necessarily a bad guess, because 1 is less than 5 and its cube root is 1, and 8 is bigger than 5 and its cube root is 2. So we know that the answer to the cube root of 5 is going to be between 1 and 2, but say you hadn't guessed that and you don't want to start with a fraction, you could always just make it 3. So to find x2, you do 3 minus f of 3 over the derivative of 3, which our calculator is going to tell us is 2.185. Finding x3, we're going to do the same process, so 2.185 minus f of 2.185 over f prime of that, which the calculator is going to spit out 1.806. And if we keep doing that same process for x4 and x5, we do 1.806 minus the function value there over its derivative there. So that's going to be 1.715. And then our last one, applying the same formula again, the calculator is going to spit out that x5 is equal to 1.710, rounding to that third decimal point. And then if you use your graphic calculator to check what the cube root of 5 is, it is approximately 1.710. The accuracy, again, is out to the thousandth or 10,000th decimal place. So another reason that using that calculator shortcut is handy is because that way you're not using any of your rounded answers when you plug back into your formula, which means that you're not getting any rounding error on the next number. So if you're doing these and you're not using your calculator to use the whole decimal and you're just using those first 3 decimal points, your answers might differ slightly from that of your professors or another classmates who is using the exact answer for the previous x value. So that's how you want to go about doing these problems. I hope this was a helpful video for you. Have a great rest of your day. Thank you so much for watching.